Standard deviation. What is standard deviation? It is a measure of the amount of variation of a random variable from the expected value. Let us take the movie review example that we took in the previous lecture. Let us consider these ratings 1, 2, 3, 4 and 5. And in our previous example, we had found expected value as 4.63 for one particular movie. And then what does standard deviation measure? It measures the amount of variation from this expected value. Let us say if one particular rating is 3, then how much is 3 varying from the value 4.63? Now you would be thinking, while I explained variance, I explained in a similar manner. I said it is a measure of the amount of variation from a expected value of a random variable. And in standard deviation, I am saying the same. Why? Because both concepts are very similar. That is, both of them are used for measuring the amount of variation from expected value. And what does it mean if something has very high standard deviation? That means the values are spread out over a wide range. That is, if for example in this particular example, in movie review example, if standard deviation is very high, that means there are many ratings which are 1, there are some which are 2, some which are 5 and so on. But if standard deviation is less, that means most of the ratings are 4 and 5. There are very less ratings which are 1, 2 or 3. That is what happens when standard deviation is less. Why do you exactly need standard deviation when you already have variance? This is an important question, right? So, standard deviation is effectively root of variance. What is variance? Variance is shown as sigma square. Standard deviation is root of sigma square, which is sigma. That is, because we used variance of x till this point, I'll use the same thing. Standard deviation is square root of variance. This is standard deviation. So effectively it measures the same thing that variance does. But what is the difference? Scale is different. In variance, what did you do? You squared the term which was deviation. Why did you square it? Because if there is a larger deviation, that is from mean, if you have one point which is largely deviating, you want to magnify this deviation. For that particular purpose, what did you do? You took the difference, the deviation, you squared it and then took the expectation. That is what you did in variance. But in standard deviation, you are taking square root of that term, which means you're bringing this back to normal scale. Instead of the magnified squared scale, you're bringing it back to the normal scale by using a square root. So variance is generally denoted by sigma square, okay? And standard deviation is denoted by sigma, which is the square root of sigma square. So how do you find variance? Standard deviation. In variance, we told that variance is expectation of x minus expectation of x, the whole square, right? This is how we found variance. So how will you find standard deviation? Simple, just put a square root on this. Then you become standard deviation. And what was this is standard deviation now. What is the other form of variance? We also said the same thing can be found out if you do expectation of x square minus expectation of x, the whole square. If you do this, again you will get variance. So if you want standard deviation, what would you do? Put a square root. Then this is standard deviation. The only thing you have to remember is standard deviation is a more intuitive measure of dispersion, and it is more important thing is that it is directly comparable to the original data, and because of this it is a more intuitive measure. Why? Because when it is directly comparable to original data, as it is in same unit, it gives you more insights about the original data. You will clearly understand how much your data is deviating. That is why standard deviation is used.